Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Azrul Fazli bin Muhammad Fazli. Today I would like to present my FYP project. The effect of swirl air entertainment on crude palm oil using computational fluid dynamics. First is problem statement and objective. Due to the high cost of lab or workshop experiment, the shape of the swirl air entertainment is difficult to analyze. Thus, using the CFD method, it is hoped that the result obtained will be much clearer and more accurate, and will not only save cost but also time in carrying out this research. Okay, for the objective, first to investigate the effect of this different swirl velocity on the swirl air entertainment of crude palm oil field. Second, to investigate the effect of different injection pressure, different ambient pressure, and different ambient temperature on the swirl air entertainment of crude palm oil field. Next is scope of the study. First, the nozzle was held fixed at 0.16 mm orifice diameter with 6 holes respectively, and the nozzle orifice injector angle used is fixed at 15 degrees. The injection pressure is at 80 MPa, 100 MPa, 120 MPa, 140, 160 and 180 MPa. The parameter for ambient pressure is manipulated at 4, 6, 8, 10, 12 and 14 MPa. The swirl velocity is varied at 10 ms, 19, 30, 40, 50 and 60 ms. And the last one is ambient temperature is at 850, 950, 1050, 1100, 1150 and 1200 Kelvin. We can see the parameter at the right side. Next, the methodology. For the methodology, first, understanding the AN170010 software, problem statement. After that, literature review, modeling geometry, meshing geometry. Next is boundary condition. Then run the simulation of V10 spray. If valid, we go to the next process. If not valid, we go to the meshing. We go back to the meshing geometry. Next is data validation. Then plotting graph. If we satisfy with the graph, go to the next process. If not, we go back to the plotting graph. Then data analysis, and the last one is discuss and recommendation. After that is experimental setup. First, geometry modeling of injector. We use a Toyota Hilux 2.5 STD manufactured by Denso. Diameter hole is 0.16. The number of hole is 6. The angle spray is 15 degree. Next is swirler modeling. The inlet is adjusted at angle of 1 degree and screw to the right. We can see the combustion chamber and the swirler picture on the right side. Okay, next is a computational method. First, identification of problem. Second, pre-processing. The third is solver, and the last one is post-processing. Pre-processing of simulation. First, meshing. Second, third and fourth is boundary condition. Second picture show us the inlet of the swirler and inlet of the injector. Third picture show us the outlet of the combustion chamber. Fourth picture show us the wall of swirler, combustion chamber and injector. The properties of crude palm oil CPO used in this study. We use a B10, 90% diesel, 10% CPO. Thermodynamic state is liquid. Molar mass is 1, density 837.66, specific heat is 1875, specific heat type is constant pressure. Next is result. First is injection pressure. We can see the parameter. The ambient pressure, ambient temperature, swirl velocity is fixed at 4 MPa, 850 Kelvin, 19 ms. The change parameter is injection pressure, that is 80, 100, 120, 140, 160 and 180 MPa. The first graph shows us the graph velocity against the injection pressure. The graph shows that the increase the injection pressure, the velocity of crude palm oil also increased. The right side, the second graph, show the penetration graph against injection pressure. For the spray penetration graph, it can be seen that the spray penetration is increased when the injection pressure is increased. When the spray penetration increases, the fuel droplet size become finer. The air attainment increase and the spray injection become more finer. We can see from the right side picture, the 180 MPa have the longest penetration than the others parameter. Injection pressure increase, velocity of fuel injection also increase. Okay, next is ambient pressure. The parameter injection pressure was fixed at 100 MPa, ambient temperature fixed at 850 Kelvin. So velocity is fixed at 19 ms. Ambient pressure is changed at 4 MPa, 6, 8, 10, 12 and 14 MPa. The first graph shows us the velocity graph against ambient pressure. The graph shows us the increase the ambient pressure, the decrease of the velocity of crude palm oil. The second graph, it can be seen that at ambient pressure of 4 MPa, the velocity of spray produced at the beginning of the injection is the highest, with velocity of 322.659 ms, while at ambient pressure of 40 MPa produce the lowest velocity of fuel spray, which is 311.922 ms. The next graph is a spray penetration graph against ambient pressure. The graph shows us the more the ambient pressure, the less the penetration. The ambient pressure resists the spray when it injected through the nozzle, due to the loss of momentum of fuel spray as it leaves the injector. We can observe the trend angle from the picture. On the right picture, we can see that the 4 MPa has the largest angle than the other parameter. Due to the loss of momentum at the early stage of the injection, the increase in pressure in the combustion chamber create a smaller spray angle. Next is ambient temperature. Okay, for the parameter, the injection pressure is fixed at 100 MPa, ambient pressure is fixed at 4 MPa, and the swell velocity is fixed at 19 ms. The first graph shows us the velocity graph against ambient temperature. The greater the ambient temperature, the velocity of crude palm oil is decreased. Then the second graph shows us the spray penetration graph against ambient temperature. The graph shows us a higher ambient temperature make the fuel vanish quicker in the combustion chamber. So the graph shows us the greater the ambient temperature, the spray penetration will be also decreased. It shows that the spray penetration of 1300 K appear to be shorter than the other ambient temperature. Ambient temperature contribute to the change formation of spray in the combustion chamber, especially in its angle size of spray. Figure at the right side show us the parameter, the increasing of the parameter, the size angle of the spray penetration will be increased. The spray tends to evaporate and disperse easily as the ambient temperature rises. This leads to the wider fuel spray angle. Next is for swirl velocity. For the parameter, injection pressure, ambient pressure and ambient temperature is fixed at 100 MPa, 4 MPa and 850 Kelvin. The change parameter is swirl velocity at 10 ms, 19, 30, 40, 50 and 16 ms. It can be seen that the higher the swirl velocity, the better the mixture of the fuel and the air in the combustion chamber. We can see from the right picture show us the flame from tends to spread more rapidly as the swirl velocity increases. So, this result shows that swirl velocity of the combustion chamber affect the spray formation and combustion of the air-fuel mixture in the combustion chamber. Okay, next is conclusion. For the conclusion, the higher the injection pressure, the higher the spray penetration and the velocity of the fuel spray that come out of the nozzle. The velocity and spray penetration decrease as the ambient pressure increases. This is caused by limitation from the presence of ambient pressure in the volume chamber where the fuel spray is resisted. The angle of spray also decreases. The higher the ambient temperature, the shorter the penetration length of the spray and the wider the spray angle. Higher ambient temperature produces better atomization of the spray as it appears to evaporate more quickly. And the last one is, mid of swirl velocity is better than other parameter as it is an optimum velocity for the air that will enter the inlet of the swirler. Thank you for your attention. That's all from me.